Wow, hello. Welcome. I just realized I don't have coffee. Oh, we're about to do some more vibe coding. And we're gonna take a look at some interesting things we've already vibe coded. Now, with the case of us essentially not so much focusing on debugging, figuring out why stuff is wrong, we're gonna use Grok to not only code for us. I tend to try and figure out stuff on my own sometimes, so you know, I do like to do debugging, believe it or not, figuring out why stuff doesn't work. But we'll try and get Grok to also do the debugging for us. So here's some stuff that we've already done within the science space. Let's take a look here. Electromagnetic field. So we spoke about this last time. Basically, an electron moving through time and space. Normally, of course, on a wire, electrons moving through a conductor. Let it be copper, let it be silver, gold, whatever floats your boat. But we were discussing a little bit about what happens when an electron moves through time and space. And it leaves off these vectors. These arrows are vectors that represent a motion or a direction. So there's kind of a, well, if you look at it from this side, a counterclockwise rotation. This is the magnetic field. This is what charges our wireless devices whenever you have wireless charging and stuff involved. This is also what kind of essentially works to create wireless waves overall. A wireless router. Basically, to remove the wires, we depend on this force, this electromagnetic force, to replace a wired connection. Wireless headphones, all kinds of stuff, which I'm not a fan of. I'll tell you, I'm not really a fan of anything wireless near my head. But that's kind of a different story. I just don't feel like uh, a long-term exposure to these magnetic fields is a good thing, put it that way. That's one thing we did here. Another one was a gravitational simulator of basically observing objects falling on the ground with the options of checking out some specific types of gravitational meters per second values on different planets. Titan, I believe, is a moon, Pluto as well. So we can change the value and observe what that looks like. Imagine this is like a apple falling from the tree, right? Of course, on Earth, there it is. Of course. Mercury, a little bit less, so slower fall, and so on. So the cool thing about any sort of like simulation, especially when, again, I spoke about before, Grok can do images. Grok can do certain adjustments to visualize things, but we don't normally think about, hey, Grok, in code, show me how this part of science works, right? In fact, I'm thinking about a rocket ship now. So let's see. Let's try this out. I'm getting a feel, a vibe going over here. Uh, Using HTML JavaScript, create a simulator that shows or that portrays a rocket ship leaving a planet like Earth uh, while using adjustable values such as thrust, force, and other attributes of the rocket ship itself. Also add in different values for gravity based on the planet the rocket is leaving. Provided that the rocket is leaving Earth, gravity and force, resistance, will be one value, and leaving Mars a different value. On top of this, create a visual simulation using our favorite 3.3JS that will display this simulation visually, and a button that will activate the simulation after the user adjusts all the attributes to their desire. Let's see what it comes up with. Now, there was another one that kind of didn't work so well. Someone wanted to request a... Where'd it go? Where'd it go? Gravity simulator, toroidal field, snake. Oh yeah, the snake game too. Oh, we did a lot of snake game stuff, huh? Where'd I put it? I think I gotta go through history for that. Oh, it's done. Alright, cool. It doesn't look like it's crazy. Okay. Let's see if this works out well. So here's the things we can actually get out of it too. We can go through, if we understand just a little bit of code, we can observe the equations that Grok uses. Now again, not only can Grok code in a specific programming language, but it's able to, and it knows all the general values necessary for us to create that simulation, which is great because instead of like going crazy on the research, trying to figure out drag force and pieces and pieces and pieces, and then put it into a specific program, we can let Grok do that all for us. And let's see what we came up with. Rocket Sim HTML. Oh, I'm liking this already. Launch. Launch? No, nothing, nothing. Earth. Okay, so we got Earth and Mars, but we gotta add. Oh, it's moving. It's moving ever so slightly. That's so cool. Now there's other values like rocket mass. All right, thrust, cool. Drag coefficient, nice. Cross-section area. Interesting. Oh, there's no reset, is there? Oh, well, I didn't put a reset button, so we're just going up. We're going up. Ah, but we do have to add in the curve, the orbital curve. Okay. All right. Now let's add more planets to the list based on our solar system around the sun, as well as add a orbital pathway that rockets use to leave the atmosphere in an efficient way. Also, please add a reset button. Okay, gotta make that reset button happen. That's very good. Planet radius, very cool. So how does it draw, launch, add, animate? Okay, so we're requesting animation frame is launching, super cool. Time minus last time, divided by 1,000 milliseconds, nice. The difference in time. dt acceleration times dt, velocity times dt, very cool. I'm loving these ideas. Okay. Planning orbital path, adding a launch angle input could help simulate thrust direction for orbital paths. Man, this one's gonna be a little bit of a difficulty. Because I mean, yeah, we kind of have like a very straight up. Okay, let's reset by refresh. What if we had a thrust of 550,000? Imagine us launching out in space like this. That'd be insane. What about Mars? Does that change? Well, yeah, it's gonna be much easier actually to leave Mars because the gravitational is much less. Cross-section area. 1 meter squared? Is that really the tip of the rocket? 1 meter squared? That would mean very low friction when it comes to the actual rocket ship. That's pretty sick. That'd be really tiny rocket though. It'd be just like a one-man rocket, I guess. That makes sense. That would be more like a capsule pod, no? Okay, interesting. Adjusting physics units. Simulation needs consistent units for physics visualization. For orbital path using radial gravity. Real scales. Orbits hard to visualize due to large numbers. Okay, so they're reducing the number values. Horizontal velocity. It could align with its direction. Yeah, the rocket currently stays upright, just as if it's like leaving straight up into the atmosphere. Could we leave with like 500 thrust? That'd be really slow, wouldn't it? Oh, they changed the Mars color. Nice. That's a nice little effect. No, it's not moving, is it? There's no way it's moving. 500 newtons thrust. Come on. I believe in you. The tiny rocket that could. All right, there we go. I'm gonna copy this one and then modify. The cool thing about these sort of little applications is not only are you kind of basically learning science in a general sense, but also seeing how the program is organized. It helps you with experience, especially if you're reading the code. Because yeah, it's really easy to tell Grok to do something and then copy and paste it. But analyzing the code itself is the important part. Adding event listener to the click of the reset. Okay. And then launching false, position set 0, velocity set 0. So basically these are the variables that are getting reset after we click the button reset. Orbital trajectory, nice. Small initial kick for gravity turn. Oh, that's nice. All right, let's see what came up with that. Oh, I'm not liking the blink. Okay. Oh, no. Oh, what? Our rocket is a cylinder. Ah, we have orbital path abilities. Okay, okay, reset. So what do we do orbital path? Not really showing it. Thrust. Oh, we're on Mercury. Let's do Earth again. Oh, the rocket ship is also changing based on the size. Nice, nice. But that's not doing an orbital path. What about if I do like a 10-meter squared radius? About 100. Yeah, it's gonna have much more friction in the rocket's path. Drag coefficient, what about 2? Ooh, yeah, more friction. Interesting, interesting. Not quite. There's some things that need to be adjusted for the orbital path. It shouldn't display the rocket leaving straight up, rather show a sideways orbital uh, arc exit from the atmosphere to minimize friction. Right now, it does the same visual simulation as the straight up uh, straight up trajectory. Okay, so maybe it is calculating it based on the orbital process, but it's not applying that to the visual simulation. What else do we have here? Toroidal fields, games, Grok, Snake, Snake. Yeah, there was that. Oh, wait, no, it's going. I made Grok make a democracy-based simulator based on your typical political concepts. But I do want to adjust it for a third party, given time, given the idea that pops up. Hmm. I mean, okay, kinda. All right. That does seem pretty decent. Let me do like a scroll wheel zoom in, zoom out. Can we add? Can we add a scroll wheel zoom in and zoom out of the whole simulation to get a better view of the overall sim? So, what if we were leaving Neptune? Damn, Neptune is huge. That's cool. That seems appropriate. Yeah, it would take a bit. I'm not a rocket scientist, so I can't vouch for this, but that seems pretty appropriate. That's only 1 ton though. Aren't rockets much heavier? Depends on the rocket, I suppose. Oh, it made it so heavy. Is it moving? I wonder if it's even gonna leave the atmosphere. Hold on. Nope. Oh, it looks like it's getting tinier. Hello? Are you going into the planet? All right, so obviously that's not gonna work. How about a little more thrust? Yeah, okay. There we go. That's so cool. It's crazy we can do this now. It's so crazy we can just create random tools based on scientific knowledge. Noise, zoom event, wheel. There it is. So add event listener wheel, zoom minus event delta Y. Oh, that's how we do zoom. Then math max min zoom, math min zoom zoom. Got it. A little bit of a mathematical conundrum. Can we? Let's see. Hmm. does not look good. Something broke. Mm, okay, nothing's showing. Gotta let Grok know. After this change, launch simulation does not begin the process. Does not begin the simulation and does not show the planet or rocket working. No errors in console. That's weird. And there's definitely nothing in console. What I'm gonna do though, Control Z backwards, make a copy. I like to keep copies of working code. Because sometimes Grok can give me a new set of code that doesn't necessarily work, which happens, as AI isn't perfect. No, cat. No. Ugh. Why you gotta scratch me? Looks good. Okay, we back. Ah, yes. Zoom is working. Good zoom. That's sick. All right, so straight up or orbital path. Let's go. It's doing it. It's doing it. Jeez. Okay, okay. So it's a good start. Now I want to expand this. I want to expand this. Can we add a HUD with the details of the rocket's speed, distance from starting point, and distance traveled? Also, the rocket is not rotating anymore as it used to, and the planet's color changes to gray. Let me see if that's consistent. Because, oh, we're in Mercury. No, that's fine. Earth? No, that's fine. I guess Mercury is just gray. That's how rockets work, guys. Alright, hold on. That's not a necessary thing. All right, what planet should we do next? Let's see. Uranus or Uranus. Oh, okay. Wish it rotated though. It's just straight up cylinder. I like the zoom in, the zoom out and in. It's pretty good. It's pretty good. I want to expand this to be like a traveling simulator. So we can potentially start from this and then recreate the full solar system and basically have that rocket traveling from planet to planet. Now the key here is we need to fast forward because that would take a long time to show. Where's the rocket at? Jeez. Okay, so like that, I'm going to copy paste the sim, grab the new code, save that. Start from Earth. Oh wait, that's straight up. Wait, huh? Where's the HUD? Is this? Is this? Oh, no, where's the HUD? I don't see a HUD anywhere. Where's the display of data? Hold on, Grok, what you doing here? Update planet, planets, data Earth radius. We'll click, thrust, launch, cross section. Where's the HUD though? Didn't you say? Can we add a HUD? Yeah. Planning code changes. The task is to add a HUD showing rocket speed, distance from start, distance traveled. Since it's a web-based simulator, 3JS element added for the HUD. Implementing added a style div. Okay. Let's track distance traveled by adding velocity times for each frame. It's just about writing the code. Yeah, no tools externally at least. But where's the freaking HUD, bro? I see trajectory straight up. The options for the planets. Launch. Oh, there's the HUD. Okay. So where's the HUD? HUD element. Okay. HUD.inner HTML should happen when it's updating. Yeah, right? This is in the animate? Yeah, it's in the animate. Oh, you know what? This might be because it's an HTML value. This might actually be rendered underneath. Wait, there is no HUD. It's not actually being displayed at all. Huh. Okay, if we start, it's moving. Got the render here, which is the canvas. Controls. Trajectory, mass, number, thrust, reset, launch. Where's the HUD? 0 of 0. Okay, so it's not being displayed then. The HUD div doesn't seem to be displayed on the page, even though I see the code entry. Live, it doesn't show on the actual page, nor does it exist in the HTML elements. What's up, 5Quest? We are doing science. I'm using a Grok 4 to create simulations for a rocket set or space simulations. In this case, we've got ourselves a simple rocket cylinder using the mathematics involved in the back end. And we've got Earth, Mercury, Mars. I'm just kind of taking it a step at a time, expanding on the simulation. But launching the simulation, although it's not, my rocket's not rotating anymore, unfortunately. It's kind of non-rotationary. I have to modify that or figure out what Grok is doing in the back end. But basically, using Grok to create our own simulations in a vibe coding environment. Let's see what the new one looks like. Oh, hold on. Is it done? No, it's not done yet. If you have any ideas, shoot them in chat. I'll see if Grok can handle the simulation. This is a great way to essentially take a physics or scientific concept and make it live. And kind of gets you a little bit introduced to coding. Okay, that's a straight up. But the HUD's still not visible. And we're using JavaScript as our mechanical backend, HTML as our document front end. Oh, why isn't it visible though? I see it in the code. So it should be controls renderer. It should be between the controls and the renderer. There's a HUD. There's the controls. So then the question is, why is it not visible? Why do we not have the HUD in our HTML code? It should be between these two. Still the same, right? So div ID HUD, that's where the display should be. Hmm. Why? Okay, what are you thinking? Grok, tell me what you were thinking. HUD mentioned isn't showing the page despite the code presence. The HUD in the rocket launch simulator code should display speed, altitude, and distance. It's odd the user said it doesn't exist in HTML elements as the code shows it's there. Perhaps the user is running it and the div is there, but since initially empty, and if animate doesn't run, but it should. Maybe the HUD isn't visible due to its position, as it's set in absolute bottom left. The renderer div being full screen and the last DOM likely. Yeah, it would be the case, but oh, there's my magnetic field. But I would at least be able to find it in the search here. Alright. Still, HUD doesn't get displayed on the live page. Even searching with find for ID equals HUD shows nothing to display. Shows 0 results. Is the JavaScript overriding the entry or removing it by accident? Sometimes you gotta guide the AI just a little bit. Sometimes when we do JavaScript modification of the document object model, the DOM, we may accidentally delete it or remove it. The code includes div with ID. JavaScript manipulation should be in the DOM. The HTML shows a HUD div between controls and renderer. That's exactly what I was looking for. With Z index 10, the HUD should appear above other elements, but it's not found. So that's the other thing. I thought it was like pushed behind with the CSS. And it looks like, yeah, they put a Z index 10. So at least it tries to pop up above the simulator. Something weird. Okay, let's try this. Can't stop, won't stop. Okay, can we find HUD now? 0 for HUD, man. Oh, wait a minute. Am I doing retard? I am retard, aren't I? Hold on. I wasn't modifying the right thing. Yep. I'm dumb. I was literally... Oh no, I'm dumb. I was modifying the copy and loading the original. Okay. Okay, straight up orbital path. Okay, a bit of a quick rotation, but that's fine. We can zoom in and out. Very cool. Distance, speed, meters per second, altitude, distance traveled, 15 kilometers. I mean, this is really small level stuff compared to the overall system itself. Okay. It is technically continually going around the orbit. You can see the rotation, so Mercury must be to the top right. Let's do Earth. All right. I think we're ready to expand it once more. Okay. All right. All right. Looks good. Now let's expand this simulation to the whole solar system. Add in the rest of the planets. Scale them proportionally but realistically. And let each second, how much would a second be? Well, I think that's going to be a case for a drop down because we might want each second to be a minute so we can speed up the process. Or no, hold on. And add in a speed up and then a slow a time speed increase and decrease button. Also add in a source liftoff planet and a destination planet. And then provide the accurate travel between these planets. I think I broke it. I might have to start anew. Hold on. Dot dot dot. Are we working? Did I break you, Grok? Yeah. Scaling distances and sizes realistically is tricky due to huge solar system scales. Adjustments are needed for large scales. Currently looking for real relative sizes and distances for planets, including Pluto. Calculating. Real planet position on July 12, 2025 can be found using astronomy libraries. Nice. Oh, cool. Look at that sucker. Oh, look at this. Oh, Python? It's using Python to find some details. Ask Choppy. I like that. That's really cool. From Astropy coordinates import solar system ephemeris get body barycentric. Import time with solar underscore system ephemeris set DE430. T time. Oh, you can find the positions of all the bodies using Python. Saved. Extra code. I like it. I like it. Hold on, hold on, hold on. I love bonus code. Where'd it go? Hold on. Where's my Python? Well, let's do it in here. Python. What is it? Planet details.py. I like that a lot. More code from solar system bodies. That's so cool. So what happens if well, I gotta probably install this package first. So Python install Astropy. Oh, of course I gotta do, sorry. Dash M pip install Astropy. So we're gonna install that Python library. Search for heliocentric positions of planets in AU on July. Browsing online Saint Gerneskin. Browsing the Sky Live. Browsing. Executing more code. T time T.JD. What did that do? Kitty cat, you're gonna fall. Wrong direction to lean, bro. Lean this way. There you go. My cat almost fell off my lap. Alright, now I can run. Right. Ooh. Oh, what this? Line 5, planet details 5, with solar system affairs set DE430. Line 66, file, try spec. What's the issue? Line 137, kernel, and get kernel. Solar system JPL FRS calculations required at JP. Oh man, that's just a usage issue. That's a whole next set of. Oh, wait, no, it's not. Maybe I need that. Python and pip install. No module named. Oh, wait a minute. I have the dollar sign in here. There we go. There we go. Okay, how about now? Can we run it? You gotta make sure all your dependencies are in order. Some packages require yes. Require other packages. Oh, what this? Ah, we're downloading some planet details now. Nice. Okay. Fun. I love new resources. Whoa. Are you making this in Python or in JavaScript? Because I thought we agreed upon JavaScript. I mean, I'm not complaining about the extra. Oh, it's still thinking? Damn. Oh my God, it's going through the full. We're literally creating a NASA level simulator right now. That's insane. Oh, look at that. Sun coordinates, XYZ. Oh, that's insane. Mercury coordinates, XYZ. I can make an astrology calculator from these coordinates. Oh, that's cool. For those that like astrology. Hmm. Earth Moon Barycenter. Okay. That's got to be something in the center point between the Earth and the Moon. I don't even know. Very cool. Okay, so this is the bodies involved in the solar system. So Earth, Sun, Moon, Mercury, Venus, and all those pieces there. Print positions. Positions are all of these. Cool. And then what was the other piece of code? What's this one? Import math. What are you calculating here? I guess it's using the values. It's using the values we just pulled, I think. So it's actually, that's sick. Grok is actually taking the values from the previous sets of code. He's using code to make more code. That's sick. He used the same pieces of code here executing Python on his own behalf to gather information like these details we just discovered of the coordinates and positions of those planets, and then apply them to a new set of code to create some more algorithms. I'm not even sure what they do, but we're about to find out. All right, so that's cool. I guess they're more calculated based. Planet calculations. .py. What do you do? Ooh, what that do? Let's see. Mercury, values, XYZ, XYZ, XYZ. So degrees to radian. Name for each name in P in planets.items. Planets comes from here. So we've got name of the planet and P for all the P values inside. A, E, I, Omega, Varp. Oh, I'm not a rocket scientist, so I cannot identify these variables. But they've got to be something to do with location in space, distance. That's sick. But I know nothing about this rocket science stuff, yo. Still makes me excited. Okay. That's Grok is still going, by the way. Oh, he did it. Thought for 10 minutes. Let's go, Grok. You are a genius. You are the absolute mastermind. That's crazy. Grok used Python to complement the data that he didn't know in order to pull information from an online API and then take that info, save it, and then apply it in its own calculations based on possibly scientific physics that it knows, because apparently Grok is like top tier student, college student or whatever on every single subject. Oh, what if I told it to make like a skeletal, an accurate skeletal body display simulator? We can do biology another day. That sounds exciting. All right, so that's the new set of code. I am not that impressed with the current one. Well, actually, I kind of am, right? I did a decent upgrade. It's rotating again. So let's grab, copy, then save it. Ooh. Hold on. Mercury to Mercury. Can we do that? Can we go back to itself? Okay, well, something's up. Oh, we got errors. We got so many errors. Well, not that many. It's just repeating in a loop. All right, so let's grab. Let's grab a couple of these. Error, Will Robinson. Error. We got some looping errors in the code, sir. Let's figure it out. That's not what I wanted to copy and paste. What code line is that? 221. Constant start churn alt closest dot radius AU. 221. Trajectory. I mean, but also, yeah, 221.59 radius AU, reading radius AU at animate. Let's reset. Can't even reset? Closest dirt not defined. Oh, maybe that'll help him too. Let's see what he does with the first set. There it is, he found it. Wow, nice. I had to reset to figure that one out. Error might occur when launching with looping errors in the console. It does indeed. Oh, strudel. True. All right, let's see this out of code. Rocket sim. Hmm. Position. Ah, yeah, this is a much more complicated system. I'm probably gonna have to take some time with it and work out the kinks, but we're getting there. We are getting there slowly. So reset, cannot read position, increase time, decrease, nothing changes there. Mercury to Mercury, how about it would go from Mercury to Venus? I'm gonna do one more try here in Grok. One more try before we end. Let's see if we can get our rocket launch simulator to work. At least got some pieces going. Oh, there we go. Maybe it was a quick fix. Oh, another one should be circuits and currents. That's a nice one to work with as far as simulation goes. Yeah, I'm starting to see a pattern. A lot of attendance in the morning, but nighttime, not so much. Maybe it's game time, nighttime. Maybe I'm gonna play me some games. Let's see if my buddy's online. Do some ranked in rivals. All right, one last try. Let's go, Grok. I believe in you, buddy. No error. No, DTD day, the delta day is not defined. All right, well, I might have to fix this on my own on the side until it works, but that's it for now. I'm probably gonna play me some Rivals or some other games. Maybe stream, maybe not. We'll see. Talk to you later. If you like code, if you like science, if you like random cool music, like and subscribe. So, and also notifications so you know when I'm live next. And feel free to ask questions when you're live. And basically, give me ideas. What kind of simulations do you want to see? I think I'm going to do circuits next because I'm kind of outspaced, if you know what I mean. This is becoming a big project for Grok to maintain, so I might have to dabble in some code myself. Uh, but what kind of simulation should we make? Another one should be the solar system, right? It's like a nice clean solar system. But I mean, the best case scenario so far, we got a decent. Where's the copy that works nicely? Is the one? Nope, that's not the one. This one. Yeah, we got a nice one. We got a rocket launching off of space. That's pretty cool. It's a little bit wonky. Very, very old school graphics, you know what I mean? But we're not here for the graphics. We're here for the science. Also, we got some speed attributes. Keeps increasing speed as it gets out. Meters a second, meters a second. Now, I wanted to basically do this and then get the spaceship to land on a different planet, you know what I mean? But that's going to be a little extra work. So, cool. We did some magnetic fields. We did some space rockets. And there's more. But when the project gets heavy, it gets difficult to manage. So, I'll be back in the future. Like, subscribe, put the notifications on for my next stream.